Yes. And you look at your art, you see also as well. I think you need to start now.
It's time to start. When is your session? Tomorrow? Last session. Last session. That I need to get.
Okay, folks, welcome to BESS. Let's just make a start because we don't want to make you late for dinner afterwards. Okay, we have two blue sheets going around for three blocks of seats, but please sign the blue sheets. And when you're the last one at the back of the room, it would be really helpful if you could bring them to the front at the end of the session. Okay.
So here is a notewell. If you are not aware about it, please read it. Blue sheets, okay. So here is our agenda. So let's start. First speaker, MVP and Yang.
Thank you. I'm Guo Feng from Huawei, and I'll give an introduction for the multicast Yang models. Actually, Yi-Song has presented the multicast VPN Yang models in past IETF meetings. So today, I majorly focused on the major changes since then. Okay, here is the structure of the multicast VPN Yang models. There is no change on the structure. I just give an introduction for better understanding. First, the multicast VPN models is at the same level as unicast layer 3 VPN models, Yang models. Second, there are two levels within multicast Yang models. The first level is the VPN instances level. The second level is the PMSI level. Here we have inclusive PMSI, selective PMSI. Third, both IPv6 and IPv4, they have the same structure of multicast VPN models. And here I introduce the major changes. The first update is we introduced a new type P tunnel, which is defined according to RFC 6513. So this is the provider tunnels. So in this new type of P tunnels, we have RSVPT P2MP, MLDP P2MP, and PIM-SSM, PIM-SSM, better PIM, those kind of things. define this new p-tunnel is majorly make it easier for define multicast VPN YANG models. So this is a new type p-tunnel. And the second update, we added beer as a p-tunnel options. So here in beer, we defined under the PMSI is both under inclusive PMSI and the selective PMSI. And this is the operational state of the beer as p-tunnels. The third update is we introduced explicit tracking mode in MVPN YANG models. And it's defined under selective PMSI. Also, we have introduced upstream VPN labels. This is for the scenarios for multiple VPNs sharing the same p-tunnels, provider tunnels. And those are the major changes since then. And we'd like to have more comments from you and prepare for a Young Doctor review.
I'm Rashad from Cisco. I just took a quick look at the model. There's actually many errors which you might not see on the data tracker page. But if you go to YANG Validator or YANG Catalog, YANG Validator, I think some of the base models you're using have changed and your augments are incorrect and all that. So it would be good to fix that first.
Okay.
I can show you the errors I'm seeing if you're interested.
Okay, I'll go.
Yeah.
Any more comments?
Yeah, one comment. Stefan Nikowski speaking as individual. I think as part of this model, we need also to think about the extension to the base BGP model. So I have started to contact the guys who are editing the BGP YANG model to try to agree on what is under their responsibility and what should we do as part of the BESS work. So globally, the conclusion seems to be that we, as part of BESS, should be responsible to add a kind of BGP module that should augment the BGP YANG model to provide the AFI and associated container, but also the extension to the routing table. So to be able to get, for example, the BGP local RIP for MVPN or EVPN or L2 VPN or whatever address family that we are creating that are not fully supported in the base BGP model.
Thank you.
Next speaker, Luton. It's the wrong version, I think. Yeah.
Good evening. My name is Luc-André Burdet from Cisco. I'll be presenting updates to the L2 VPN and EVPN YANG models since the last IETF. So we had several meetings since Prague offline, but we followed up with another one during this IETF week with all the stakeholders to close on many of the open issues that we were still having, including some of the issues that were raised already on the mailing list. This was done last Tuesday. Three of the major conclusions from this meeting is that, first of all, the models proposed use MPLS encapsulation as the de facto. And what that means is there are references to, for example, VXLAN encapsulation in these YANG models. And following that discussion, the base concept here would be that these drafts propose essentially a foundation for the encaps other than MPLS, but do not define them. So there is some cleanup to be done there. The second conclusion is that the focus is now basically on consensus on these models, not 100% completeness with everything EVPN that is out there. So we do have alignment across the L2VPN, L3VPN, and EVPN models. And some of the main pending actions we have, other than the nits and corrections, are to add an appendix in the EVPN model with examples for EVPN-IRB, EVPWS, and to make some of the choice names we have in the models less restrictive for future extension. So the L2VPN model is pretty much completed. As part of the conversation on Tuesday, the authors felt that it was necessary to add IRB interfaces for completeness to the L2VPN model, and that one of the major conclusions we had was that essentially the EVPN instance in the EVPN model would augment the L2VPN model. And there was a discussion at some point around once we settled on this augmentation of L2VPN by augmentation of L2VPN by the EVPN instance, then the conversation turned to having potentially more than one EVPN instance in an L2VPN. For the EVPN model, it's less complete, so it has still several minor updates to be made. So we do have a list of those. The more striking examples are, for example, moving the ingress replication to be attached per EVPN instance rather than the way it's currently defined, which is global per EVPN, or so global in the model, sorry. And as I mentioned previously, some of the things like AC or pseudo-wire choices should be made more generic to be extensible in the future. One idea that came up would be to create a base identity for load balancing. So currently load balancing is defined for all active and single active. But there are other modes being defined already, and that I think I presented in Prague. So the idea would be having a base identity that can be extended. And there was a conversation around split horizon group for EVI, so it'll be completed for that. Like I mentioned, one of the major updates is actually including an appendix with examples of how to use this model. So typically, or namely for EVPN bridging, for EVPN IRB, and EVPN VPWS use cases. So we will require one more revision of the EVPN Yang model.
Okay, so same point as I mentioned for MVPN, there is a requirement to create a BGP EVPN and BGP L2VPN model as part of the same draft, but separate module that should augment the base BGP Yang model.
Yeah, so I spoke to the authors of the BGP base model, and we are aligned in terms of our references to RFC 8294, if I'm not mistaken. But they define a node that the L2VPN and EVPN models should attach to and extend. So we'll be doing that.
This is Himanshu from Siena. I don't know whether you just touched upon the topic I was going to make a comment on, but I know that Stefan and Jeff are discussing the BGP RDRT inclusions, and I haven't followed up the thread, but I want to know whether that means we have to do some more work, or what's the deal there with respect to the RDRT types and BGP related stuff, the policies and...
Jeff has, so the base BGP model right now is where some identities like AFI, SAFI live right now. We're in the process of figuring out, what module ends up owning those and where they get extended from. There are two options open for each of those. One of those is to have it IANA managed and it just gets extended there. That makes it fast to revise, but since this is one of the things that in Yang that you can revise in the individual module, that's also a possibility as well. The inclination that I'm pushing right now, and please keep in mind that I've just started helping out with this. This is long-standing work, is that things that are extensions to BGP that are tied to one of the VPN service models, should actually go in, by augmentation when possible. If you can do that, it means that the Yang design of the base BGP module is doing its job. And you're going to probably end up with separate submodules such that you can add the BGP pieces in your model, and therefore BGP can operationally handle the protocol components. So you can do a show BGP and see, here's this AFI-SAFI, for new address family, and here are the counters for it as an example. And you can have policy extensions to the IETF policy module that lets you interact with these things at a BGP level, but it's potentially possible that the service model may not yet be implemented. So by having these things as structurally separate, it means that BGP can be used, policy can be used, and service models can be used somewhat independently of each other in terms of implementation. Questions?
My only question is, what do I need to do on the L2VPN Yang model? Can you?
We'll take it to the mailing list.
Okay.
AC Lindum, I heard Jeff mention the address families, and they are all defined in 8294. I'm not sure about the BGP, all the SAFIs, but at least the address families are all there.
What?
Okay.
In any case, we are always creating new AFI-SAFIs.
Yeah, the comment I just made to AC that people couldn't hear is that these are a tuple. There's AFI-SAFI as a BGP thing that is somewhat separate from what's in the IANA module.
On the encapsulation specific parts of the model, I think probably we need some discussion between the chairs of different working groups that own encapsulations that are applicable to eVPN and L2VPN, so that we have kind of a modular approach where maybe the working group that owns or is largely developing that encapsulation technology does the model for the encapsulation, so we don't risk ending up with multiple models for the same encapsulation or application-specific models for the encapsulation. So, for example, with VXLAN and in future Geneve, I think that probably would be an NVO3.
Exactly. So the proposal we had was to define the foundation so that the NVO model could then essentially extend. So we would support as a foundation any encapsulation requirements from NVO being the use case we had in mind.
Are you coordinating with your team? Because we've had some, speaking as NVO3 chair, we've had some various Yang models for VXLAN, and we've got one for Geneve and so on in NVO3.
So we had an AI to follow up in NVO tomorrow and look, yeah.
AC again, yeah, it could be a tuple, but it should, I think it should reference 8294. I don't see why. At least take a look at it. And this is an IANA maintained model. We split up the types that were relatively static with the enums for the address families and BGP SAFIs, just to in order to allow the latter model to be maintained by an IANA and periodically generated.
So both for the RDRTs and the AFI-SAFI, we do down ref 8294. The question is then just for the node attach point, we may just reference the BGP model, but that's also going to be using the 8294 type depths. Thank you.
Hello, my name is Jorge Rabadan, and this is a list of my co-authors for this draft. So this is what I want to talk about. First of all, a short refresh about what the draft is. And second point is what's new in revision 1. And the third point is next steps. So the idea behind this draft is to provide a solution for multicast redundancy. And that solution should actually work in any eVPN network. And what that means is that you may have sources that are multi-homed, redundant sources that are single-homed, or redundant sources that are multi-homed to the network. And And this should work in any EVPN tenant domain configuration, which means that the sources and receivers, they can have, they can be attached to the same broadcast domain, different broadcast domains, or a mix, right? So the idea here is to avoid the duplication. So when you have redundant sources, and what that means is, if you don't do anything special, let's say that in the diagram here, in the example, you have two sources that are actually sending the same flow, the same multicast flow. From a multicast perspective, because they are coming from different sources, they are treated as different flows. And what that means is that basically the receivers will get duplicate traffic, so they will have to deal with it. What we want with this draft is to provide a solution so that the network avoids this duplication and provides a redundant solution. So one important concept that we are handling here is what we call the single flow group, or SFG. So an SFG is basically a multicast group that represents single flow that can be sourced from different IP addresses, from these different sources, right? But those sources, they basically send the same content. And that's what the duplication that we want to avoid. So there are two solutions in the draft. So the first one is what we call the warm standby solution, or WS. And the second solution is what we call the hot standby solution. So the first one, and apologies for the slide, is not in PowerPoint. Actually, it looks nicer, but basically the first one, it's about the upstream Ps, the ones connected to the SFG sources, the ones selecting only one of the Ps as single forwarder, and the other one not sending the SFG, right? The second solution is basically a downstream P-based solution. The idea is that the upstream Ps that are connected to the redundant sources, they both will send the traffic, and the downstream Ps that are attached to the receivers, they'll pick up one of the two, right? And they will avoid the duplication. And obviously there are procedures in case of a failure of one source, the other one will have to take over, and with a fast failover. So which one is better, and why we are including both solutions in the draft? So, well, it depends on what your requirements are. If your requirement is to optimize the bandwidth consumption, you should go to the WS solution. If your requirement is to upgrade the least amount of Ps in the network, you should go to the WS solution. But if your requirement is to have the fastest failover possible, you should go to the hot standby solution. So what did we change in revision 01? So basically based on the feedback from the working group, actually in particular from Mankamana, we changed the definition of the SFG. So in revision 00, it was represented as star comma G, which pretty much means that any source transmitting that group was considered to be a redundant source for the SFG. Now we have a finer granularity in the sense that we are defining an S comma G where the S is actually a prefix, it's not a host. And so any two sources or more sources that are contained within that subnet that has a length are considered redundant sources for the SFG. And you have to bear in mind that we are allowing here prefixes to be sent with the SPMC AD routes only for the particular application of the redundant sources, only that. The other improvement that we are adding to the draft is in version 00, we had an ESI attribute that we needed to send along with the SPMC routes, but it was kind of open. We didn't say what kind of attribute it was. So here, basically, among the authors, we agreed that the best solution was to add an ESI label extended community, which is already defined in RFC 7432. The only thing is that we are advertising that community along with the SPMC routes. And then this is used for the hot standby solution. And besides that, we added some, we fixed some typos and added some clarifications. So with those improvements, this is how the warm standby solution works. You have here an example with 2 redundant sources for 1 SFG, and the receivers are attached to the downstream PEs. And again, this can be any type of EVP antenna network. So all the hosts can be attached to the same broadcast domain or different with a single broadcast domain or based on an OISM network. So here PE1 and PE2 would be configured to know that G1 is an SFG, and we could be using the representation of a star comma G or a subnet comma G for the SFG. Let's assume here that S1 and S2 they fall into this subnet that we are configuring for the SFG. And so once we do that and we start receiving traffic for the SFG, we will advertise the SPMC 80 routes, EVP and SPMC 80 routes. And those will be advertised with a DFLX extended community defined in RFC 8584. With that extended community, basically the 2 upstream Ps, they will be able to select what we call a single forwarder. And the single forwarder will be the only one sending the SFG. And the other one, in this case PE2, will program an RPF check rule to basically discard the traffic as long as the single forward is a different P. So this is the first solution. The second solution is a hot standby solution. And here you have an example about how it works. In this particular example, you have 2 redundant sources for the SFG that are multi-homed, both of them. So in this configuration, basically you need to upgrade all the Ps, whereas in the previous one, you only had to upgrade the upstream Ps. So here, P1 and P2 would be configured to know that the star comma G, for instance, is an SFG. You have the 2 Ethernet segments that are configured as usual in EVPN. And you will also need to configure the downstream Ps as a hot standby mode. And as soon as you make the configuration on the upstream Ps, there will be signaling of the SPMC routes for the SFG. And we will attach the ESI label extended communities for the 2 Ethernet segments that we have here. It's important to highlight that the ESI labels that we are using here, they are DCB allocated ESI labels, so domain-wide common block. And we do that because basically we need to make sure that P1 and P2, they use the same label for ES1, and they use a different but the same label for ES2. Because in that way we can we make sure that the downstream Ps, they can identify the flow coming from either source without any ambiguity. So after that, the ESI labels are also advertised in 80 various routes. And with all that information, downstream Ps are able to make some RPF check programming. The idea is that they will be receiving, the same SFG from 2 different sources, and therefore from 2 different with 2 different ESI labels, and they should be able to discard one of them. And of course, there are procedures about what to do in case of a failure on a link, on the whole source, etc. And we are saying that in addition to do the failure detection based on the withdrawal of the 80 routes, we also allow BFT. So basically, that's pretty much what we've done with the draft. And so first of all, we would like to thank the working group for the received feedback. And secondly, we would like to ask formally for working group adoption. We believe it's mature enough for being adopted at this point. Questions?
Yes, Greg Merskiziti. Thank you that you mentioned that so there is a BFD being to detect the failure.
Mhm.
So can you just briefly mention what BFD is doing and how it's used?
So we know there's a BFD draft for EVPN. So actually, one of the things we wanted to do is to collaborate with the authors of that draft and see if we can use it here. So at the moment, if you look at the BFD section in this draft, is just mentioning that you can use BFD. There are no details.
Okay. Okay. Let's
So-
then discuss it.
Yeah, we'll need to discuss and collaborate. Any other questions?
I just have Luc-André Cisco. I just have a quick question. If you go back to the warm versus hot standby, the differentiation between the two, is that detected based on the presence or non-presence of ESI label, or is it a local config?
No, here there is no ESI label whatsoever.
So only in hot standby.
Only in hot standby, yes.
So if I receive an ESI label, I would just basically assume hot standby. Otherwise, it may be both.
No, basically you should use either or in a single tenant domain, right? And this mode basically is purely control plane, if you will. So the upstream piece where you've configured that you may have redundant sources, they will select this single forwarder, and that's it. But there is no need to differentiate in the data path both flows, because there will be only one flow coming from one source.
Okay.
That's the idea.
And if you go to the hot standby slide, I just have a clarifying question. So you say P1, P2 advertise the AD per ES route with an ESI label from DCB. Is that replacing or on top of the regular ESEAD route? So the second line in bullet 2.
No, this is, so of course, these are regular Ethernet segments, which means that you need to advertise AD per ES routes with the associated labels, right? But you need a way to correlate a given SFG to a given Ethernet segment. So the way you do it is basically, on one hand, you advertise the regular AD routes, but on the other hand, you advertise the SFG location with SPMC routes, and you attach the same ESI label extended community that you are using for that particular ESI. And you can have multiples.
So
right?
it's in that direction. The ESED goes into the PIMSI route, not the other way around. Sorry, the label. So it's just the way it's worded. I guess I'm just confused. I haven't read the draft, but just the way it's worded here, it seems that the SPIMSI decides on the label, and that will then replace the one in the ESED route.
No, so, well, basically the ESI labels are DCB allocated, which means that they are not really, they are either configured or they are allocated by a controller. But either way, so the ESI label 1 that you send with the SPMC route in this example will be the same label that you advertise from P1 for Ethernet segment 1 in the AD per ES route.
Okay, thanks.
Okay. Any other question? All right, thank you.
Next speaker? Donald?
Hi, I'm Donald Eastlake with FutureWay. This is a pretty brief draft on the, brief presentation on the progress of this draft. So it's draft on the network layer OAM, and where that fits is described in the draft on the OAM requirements and framework. I just want to show a couple slides from that to show how this fits in. This is the typical flow from CE to PE through the Ps to PE to CE, and the different levels of OAM are shown at the bottom of this draft. So the ones that are handled by other mechanisms are pretty straightforward. Link OAM depends on the link technology. The transport OAM between the various P nodes depends on what transport you're using. There's different methods there. And the service, of course, being provided is Ethernet service. So typically you'd use Ethernet OAM end to end. So what's left is the network OAM from PE to PE, which is what this draft is concerning. And the use describes the use of BFD for that. So it uses BFD asynchronous mode, and provides proactive fault detections, basically for EVPN based on things in the pattern of RFC 7432. It covers, in the current version, MPLS and VXLAN encapsulation, the two encapsulations, unicast traffic, broadcast, unknown unicast, and multicast traffic using multi-point to point and point to multi-point. So the BFD discriminators are obtained for the BFD here via BGP. And this draft references the MVPN fast failover draft, which provides a means of distributing BFD discriminators. The changes from the last draft that was presented are to add that mechanism for distribution, to add VX encapsulation, which wasn't previously covered. And there's a bunch of miscellaneous improvements, including considerably more diagrams of packet headers. The BFD discriminators use the BGP BFD attribute, and that's pretty simple. It's shown what the value of that attribute is here. It has the discriminator and some flags, none of which are actually defined currently, but they're available if there's some future need. So the bulk of this draft is devoted to specifying the encapsulations for MPLS and it should be VXLAN as a typo there. For these different types of traffic, and there's both textual descriptions and also diagrammatic descriptions of these encapsulations. So to show the level of detail, I have a couple ones which you probably can't read, but I don't know, maybe if you download the slides and look on your screen, you can probably read them. This is MPLS unicast encapsulation and VXLAN unicast encapsulation. There's all the diagrams for other stuff in there. So I'm not claiming all this is flawless. I'd be happy to have people look at this, and if they find problems, we'll fix them. There are things that could be added to this draft, covering PVB, EVPN, or covering the IRB, integrated routing and bridging, or you could even add additional encapsulations. So those are possible things that could be added. But we think this draft is pretty good for the areas it covers currently, and it would be a reasonable draft to be adopted by the working group. Working group can decide whether it's essential or not to add these other things to the draft over coverage, which could be done after adoption, perhaps. Yep.
Jorge Rodan, Nokia. Yeah, so the draft looks much better than in the previous version.
Thank you.
So yeah, I think I support it for working group adoption. The thing that I'm missing is the how are you going to use this draft, this BFD? Is the intention to advertise a discriminator per MAC verb, per interface? You can even advertise one per MAC address if you want it. I'm missing kind of the use cases. And as I said earlier in my presentation, we need to work together because one of the use cases for me is the multicast source redundancy. And for that, I guess you would need to add also the EVPNS PIMC route to distribute the discriminators.
Yeah, we'll be happy to work with you. I think of course, the attribute with the discriminator can be included with various types of routes, but there is additional information that's probably needed to indicate just how it's to be used.
Agreed.
So.
Yeah. The other thing I was wondering is I saw in that section where you are saying how you distribute the discriminators with BGP. You talk about the MAC IP routes For unicast, you talk about inclusive multicast route for MP2MP tunnels, and the P2MP is TBD. So
Yeah.
I would assume it's a inclusive multicast route or SPMC route, but
Yes, well, yeah,
I mean, there's nothing else, right?
okay.
I mean, I was surprised to see TBD.
Well, yeah, I said there are, this draft is not, ready to go to RFC or anything. It does need a little more work, so.
Okay, let's
Yeah.
discuss.
When
Yeah.
it was, yeah, any kind of comments would be welcome on the draft.
All right.
Sure,
Thank you.
you're welcome.
Rashad Rahman, Cisco. Question, I just read the draft before the meeting. I see there's a dedicated MAC. Question for Greg too. The VFD VXLAN draft, there's been lots of changes recently and lots of questions regarding the need of a dedicated MAC. So that's something which might have to go.
Okay,
And the other question was, my MPLS forwarding is a bit stale. There's an ACH in there, but there's no GAL, so that part also wasn't very clear to me.
Yes, we'll reflect discussion, what will be resulting document on BFD for VXLAN will be reflected in this document. And I don't remember my top head, I need to look at it, but yes, you're correct. If it's MPLS encapsulation, there should be a GAL label before ACH.
any further comments or questions?
So yeah, just a question for clarification about so you're defining the encapsulation and encapsulation for BFD over VXLAN in an EVPN context in this draft, as well as
Yes.
having the separate draft which is with the IESG, I believe, at the moment for BFD encapsulation in VXLAN. I would have expected this document to talk more about how you bootstrap the BFD session with BGP and things like that in an EVPN environment, and not the actual encapsulation. Because again,
Okay,
we have other places where that's defined.
do you want to comment on that, Greg?
No.
He's a
actually,
co-author.
I do agree because we're not defining, we are reflecting. So if the working group believes that it's too much information, it's not duplication, it's just simple reference will do, that makes sense. Similar with the MPLS, as Rashad pointed out, basically it should not be any different from what we know using the GAL. It might be a paragraph without diagram, but yes, bootstrapping is the most important. We have one of bootstrapping mechanism already defined in MVPN fast failover. So if this mechanism needs to be enhanced, then definitely this is the right place to do it.
So what do the chairs think is the best path forward?
So I think we probably need to have a discussion with the BFD chairs.
Okay.
About where the BFD encapsulation for a specific application for a specific application resides, because there's this existing draft. And there's a number of encapsulations in EVPN that you can use, each of which you could put BFD over. But there's probably a more common mechanism for bootstrapping the session. Doesn't matter, it shouldn't really matter what the encapsulation is and how you bootstrap it, I think.
Yeah.
Which perhaps I can go here, because that would be specific to EVPN.
Okay. I guess there will be discussions. Thank you.
Linda?
Thank you. Good afternoon. This is Linda Dunbar from FutureWay. So here I'm going to talk more about how do we use BGP to manage overlay network. and here is SD-WAN per se, but really it's about connecting cloud and connecting dynamic locations. So this is in the format of 83, IFC 83, 88. That draft has a description on how do we use BGP to handle EVPN. So using that template, here are the co-authors, and I'll go to the detail. So scenarios, on Monday, actually, we discussed in the RTG working group about the network to cloud, different scenarios. And here we actually elaborate much more than what being discussed in the RTG working group. So for the first scenario, like homogeneous SD-WAN, we talk about like a shopping mall or cloud data center. You instantiate a virtual CPE and allow traffic to be encrypted to all your other PEs, or actually it's like remote PE connecting to all the VPN PE. So that's just showing that all the traffic from there can be encrypted to their destinations. Not showing on this picture, but it's described in the draft. I encourage people to read it, showing that the remote node in the cloud could need to connect to remote nodes through the VPN. So the traffic can passing the PE. And also that for the remote CPE, you could have, they call it internet local dropout, meaning some of the traffic don't get encrypted. The second scenario is about when we have CPEs in different locations, including cloud locations, where you have some ports, which are the existing ports connecting to the VPN service providers, and some other ports being connected to the internet. This is more applicable to enterprise themselves. They buy service from VPN service provider, and they decide to adding a few more ports to interconnect them together, and also interconnect to cloud locations which their current service providers don't provide connectivities to. The third scenario is about today's VPN service providers. Actually, many of those small service providers, even large ones, they use MPLS to interconnect all the PEs. And they do have internet dropout, a local branch out for over congested routes to be able to connect all the PEs by internet. Not all the PEs, some of the PEs, whenever there's a congestions, as a temporary solution for expansion. So in this document, in the BESS working group, we focus primarily on usage requirement, like in order to achieve this, what are the key requirements, and demonstrate how BGP can achieve this purpose. The key requirements is that three parts, right? So one part is very important for the zero-touch provisioning. Zero-touch provisioning, meaning you have a box, you ship it to your customer, they power it up, they're supposed to be able to work right away. So normally the box shipped out will have burned address to your central controller, which is not the raw reflector we talk about here. Is really a central controller, the remote device reach there, and based on the location of this remote device, the controller will designate a local network control for this particular device based on the proximity of the node. And another important part is the remote device, they may have attached applications need to reach the far end, but they don't really know where's the remote device, remote CPE, because all those CPEs can be having private addresses or may even have addresses not reachable by IP. They may have an identifier, even though they may have this 32 bits identifier similar to IP address, but it's not routable in the internet. So they need to go through their own local controller, be able to establish the proper channel, tunnel or channel to the designated peers or authorized peers. And so those CPEs can be geographically in different locations, in different cities, in different countries. Here I show that one tenant could have one CPE in Dallas, another CPE in Beijing, and they have their own local controller to be able to control the connection between them, control the authentication between them, and control the policy between them. So that's a very important part. The reason we chose BGP is because wide deployment of BGP and very minimum learning required. And also all the mechanisms supported by BGP, like incremental update, all those are already inherited there. So for scenario 1, in the document talks about how the traffic being provisioned, the example, walkthrough. I don't have time to illustrate those details. In the high level, the key deployment is like a law office, dental office. In the past, they may have just IP accessible, but because of so many cloud applications and they need interconnection between themselves securely to their cloud applications. There'll be also enterprises, which they already have campus network, and now suddenly they have lots of workload being instantiated in different locations, different hybrid clouds, and they need to have instant connection. The key thing is those devices can be ephemeral. Different from our CPE device in the routing domain, been talking for decades. We have a CPE, we configure them, and they are working. We have connection to them. The key scenario here is based on the demand, based on the application, and today they may need, enterprise may need their workload to be instantiated in Montreal, and then maybe a month later, depending on their user geographic requirement, they may need to instantiate similar application in, say, Dallas or in Brazil. And that's why SD-WAN come into the picture, being able to quickly interconnect those workload. And more importantly is once you connect to the remote nodes, and those remote nodes may need to talk to each other, so communicate with each other. The EVPN, secure EVPN as a draft, already identified for different granularity of the IPsec management, and also how to secure those EVPN when the PE is not directly connected. And over there, they have detailed the scheme on how to manage the rekey mechanism using BGP among all peers. For the second scenarios, so it's becoming multi-players. It's not just enterprise and network service providers. Now we're introducing enterprises, their network service providers, and cloud providers. In this example, it shows that my remote router is instantiated in the cloud data center, right? So in the cloud data center, normally, most cloud operators allow multiple different access. You can have IPsec access, you can have direct connection access. So as a virtual router themselves, they have different access and different connections, and they will have be able to get information on the performance of each network and make local decisions on whether certain traffic can go through the IPsec tunnel to the destinations, or they can go through the MPLS network natively without encryption. Encryption itself is very processing expensive, and the volume cannot be huge. So still, to most enterprises, it's preferable to use most of the secure transport using their direct connect and MPLS network. Only for when the other networks congested or when some traffic are not important, they can go through the internet. And in this example, I didn't show that you could have multiple virtual routers in different cloud data centers, how they are connected with each other. Yes, many cloud operators offer connectivity among themselves, but many enterprises still want to see being visible to see how they are connected. They may backhaul their hairpin the traffic all the way back to their customer gateway, and using the customer gateway to interconnect the traffic between different cloud data centers. As shown in this example, we have data center 1, data center 2. The BGP route reflector here is running in different layers, different instances from the underlay network. They are connected to the virtual devices. They connect to the remote devices, and they are managing the route between all those devices. And it's important that for some of those applications, especially zero-touch provisioning, and once the box powers on, and the box themselves, virtual or vertical or physical, they can detect the attachments. And those attachments has to be escalated to the controller to decide whether those attachments are valid or not valid. For scenario number 3, it's more about the PEs today. You are connecting, you already have MPLS interconnected. When there's overflow, there you add the internet ports so that you can utilize the internet. The key things here is actually the security, because in the past, the PEs are interconnected by the underlay network and is secure and is within the administrative domain of the operators. And now suddenly you open an internet port, all kinds of threats could come in, even though you may get a request from certain certain nodes, and there could be spoofing, there could be DDoS, all kinds of tech will come in. Another key requirement we demonstrate in the draft is talking about site-based forwarding, meaning that for certain applications, they may have application running in different sites, and it's very important for the routes to reach certain sites. This is really the policy, like you may reach certain sites, site 1, each node is fine, but in some other application, you cannot reach certain sites. So for the BGP route distribution and port distribution, site has to be included in one of the attributes. So in a draft, it talks more examples, like for scenario 1, how the device being powered up, how the client routes being distributed to other nodes, which is very similar to EVPN. And there's also for scenario number 2, that how the WAN ports need to be registered with the controller. Here in the BESS working group, we don't talk about how those encoding are done. We are only focusing on the actual content need to be registered. And in the IDR working group, we had a draft talking about encoding, but yesterday the chair asked us not to get to details to the encoding because there are many different ways to skin the cat, and IDR chairs want us to focus on the detailed requirement, the substance of content to be forwarded between the route reflector and device, and then later on we can explain the encoding. And for the client service provisioning, the difference maybe is more like the device themselves detect the routes and report to the controller, and then controller coming back with the policy of what routes are allowed, what routes is not allowed. For the allowed routes, and they will be propagated to their peers, and for not allowed routes can be dropped. Here just a summary of the control plane, the components. For the component itself, they need to, the end nodes, when powered up, may not even have an IP address, and may have a built-in ID, and which is not routable. And the ports connecting to ISPs, they may get assigned IP address. Some of the ports may have assigned DHCP, dynamic IP address, or private address. So it is important for the WAN port addresses to be reported to the route reflector. If CPE1 need to talk to CPE2 and CPE3, they are authorized to communicate with each other. Those WAN port addresses and how the private, how the net has to be propagated to the remote site. Just like ATM days, they have this NHRP for the address resolution, the local address to the WAN address resolution. Similar things has to be done here. And the third part is the IPsec management. There were lots of discussions yesterday. I don't have to get into that too detail. That's it. Any questions?
AC Lane of Cisco Systems. You certainly got your mileage out of these slides. I think this is the fourth time I've seen them.
Thank you, because we get comments and the focus is different. Here is more about walks through the scenarios and how the client being, how the device being brought up and how the flow goes through. And Ali insisted us we need to address, describe how those things are used, how BGP are used. Any other questions? Okay, thank you.
Good evening. I'm Kesavan Thilangasamy from Cisco. So I'm just presenting this on behalf of all authors. This is going to be a quick update on the existing draft. It's a brief overview. So it was originally presented at IETF 99. So what is this all about? So this draft defines procedure to do seamless interop between EVPN and MEP networks. And the same procedure can also be used to do optimized inter-subnet forwarding within EVPN fabrics. We have very good support from industry. And this is revision 4. There are some comments on revision 3, which we have addressed here. So these are main comments. One is the proposal doesn't provide true Ethernet emulation for inter-subnet traffic because we always use routing approach between two different PEs. So even intra-subnet traffic will also get routed. Then second comment is this draft doesn't cover EVPN and the MEPN gateway model. So if you look at the original draft, what we proposed, so the solution is really meant for EVPN and MEPN being on the same fabrics, but you can also connect MEPN networks to subset of EVPN fabrics. So that's not covered. So that's one of the comment. And third comment is, RP configuration needed in EVPN PEs. So in division 4, we add a new section which talks about, how to take care of TTL problems. Basically, on the ingress side, we don't decrement any TTL and we don't relate any source MAC. It'll get forwarded as it is. On the egress side, based on source BD, we will decide whether to route or bridge on the outgoing interface. Regarding EVPN gateway model, so we add a new section which talks about gateway model. And there are two scenarios where gateway model can be used. One is if you use two different tunnel between MEP and EVPN PE, then we have to use gateway model. So other thing is if MEP and PEs are connected to subset of EVP and PEs, that time also we can just use gateway model. So for RP configuration, we added more clarity. So we added a section which talks about various RP configuration use cases. And we also clarified that in EVPN fabrics, we don't have to explicitly configure RP configuration. There are some other minor changes that we've just made. So one of the command which talks about optimum forwarding can only be done if you use the same tunnel type. So that we just updated. And there are two new one that we have added to for the completeness purpose. And there were some comment that was made that even EVPN only fabrics, we need L3 VPN configuration. So we clarified that that's not needed. Then again, hosted advertisement are required for MEP and PEs. That's only when MEP and PE is part of EVPN fabrics, not for the gateway model. That also we clarified. Next steps. So this has been around for 3 years, and we have two different implementation. And again, it's already in production. We have 50+ deployments requesting working group.
Who has read the draft? Okay. Who thinks it is ready for working group adoption? And is there any objection to adopt the document? Okay, we will take it to the list.
Okay, thank you.
Okay, last presentation.
Hello, my name is Sri Hari. I'm going to present the BGP VPN services on SRv6+. All right, so talk about a little bit of background and the problem statement, and then let's see what the proposals are. Okay, so SRv6+, Ron Bonica has presented in a couple of working groups, and this is just a very short primer on what is relevant for this particular draft. SRv6+ provides a unidirectional connectivity between two nodes. It introduces programmable instructions. The draft talks about there is a segment instruction, there is a path instruction, and it relies exclusively on IPv6 data plane. We talk about BGP VPN services are on multiple different various types of tunnels, could be MPLS, IPGRE, and things like that. So let's look at the simple VPN topology as shown in the diagram here. SRv6+ underlay relies on the PPSI, the per path segment instruction. What it does is at the PEs, PE1 and PE2, they allocate the PPSI, and that is what that is used for identifying which particular CE that you need to send it to. PPSI is embedded in the destination options header in the IPv6 tunnel. And P routers are pure IPv6 capable, and they are not PPSI capable. So the PEs distribute the service instructions like we talked about, whether it is IP or EVPN NLRIs. So how do we use BGP to enable SRv6+ connectivity on the underlay? So we have the mechanism already, the tunnel encapsulation attribute that defines what sort of tunnel you can have between the two PE routers. So we're going to leverage that. SRv6+ path is considered as a tunnel, and we are going to request for SRv6+ tunnel type. And the sub-TLVs, as defined in the tunnel encapsulation document, whether it's tunnel endpoint or protocol type or the color can be used, but some of the other sub-TLVs are not necessarily needed, like the DS field or UDP destination port and things like that. Specifically, the embedded label handling sub-TLV, we are asking for another code point here. The tunnel encapsulation document talks about code point 1 and 2. I'm asking for a tunnel type, the code type 3, which indicates that at the ingress, when you have this particular tunnel type, the encapsulation, the extended label handling sub TLBS3, you're going to use the PPSI and embed in the destination options header. So in other words, the L3 or EVPN encoding treat the PPSI as an embedded label. Some coding encoding examples, I've only taken two. The AFI-SAFI 128, as well as the AD route on the EVPN side. You can clearly see that all others are maintained except when it comes to the label field, you embed the PPSI identifier. And along with that, you will be sending the tunnel encapsulation path attribute where you say the SRv6 tunnel. Sorry for that. Don't know what can be. Okay. And moving on. The proposal on the various BGP procedures. On the egress PE, the PPSI is associated with a forwarding table, and that is used for demuxing in the data plane. And PPSI is encoded as the embedded label, like we talked about, and the tunnel encapsulation attribute is advertised with that NLRI. And the ingress PE, the PPSI is constructed with the embedded label that is 3 bytes, and appending the top order byte as zeroed. That's the PPSI that is used in the destination options header that the Ron Bonica's draft talks about. And this tuple, the PPSI identifier and the prefix, is what that is programmed in the SFIB, the segment forwarding table. Now, when in the actual data plane, in the destination options header of the tunnel, outer tunnel header, the ingress PE inserts the PPSI in the destination options header. The P routers do not process it because this is the destination options header in the last header. So it's only looked up by the final egress PE, and that is what that is used for identifying where to send the packet to. Questions, comments? I'm going to present this in IDR working group as well. So any comments?
Hi, Jorge Rodan, Nokia. Yeah, a few comments. So the first one is the title of the draft says IDR, but I really think it belongs in here. So it's a BESS draft.
Sure.
Yes, exactly. This was a comment that I wanted to make. This is clearly a BGP service like the SRv6 VPN. So this is a work that should fall into BESS responsibility.
Sure.
John, do you have any objection? Okay.
Okay, I'm going to repost it.
Okay.
This is still an individual draft, so.
Yeah.
Yeah. Second comment, when you describe the NLRIs for different route types, you say label equal PPSI, but I really think you mean lower 24 bits of the PPSI.
Right.
So
I'm going to rewrite that.
You should correct that.
Sure, I'm going to rewrite that.
Next comment is that there's a section that you say that the label is downstream allocated except for P2MP. In that case, it's upstream allocated. But there is no P2MP in here, right? And there's for EVPN, there's no multi-point tunnels.
Multi-point down.
So you should remove that part of the that section.
Sure.
And finally, well, you are asking for a working group adoption, but I think there's still a lot to go till that point, right? Still, first it has to be adopted in the spring, and then the headers, and then this is probably the last step.
Sounds good. Yes.
Right. Thank you.
Thanks.
K. Patel Arcus. I think the draft is very well written. I went through it. I may have missed out, but in control plane, when you carry this attribute, you are expecting it to be stripped off at the ingress router, the tunnel, or you want to leak it further?
If the SRv6 plus NLRI is going to be propagated, then tunnel encapsulation attribute has to go.
Even if the next hop gets rewritten?
Even if?
The next hop gets rewritten?
Sorry, I didn't follow. Even the next hop?
Even if the next hop gets rewritten at eBGP boundary?
Next hop gets deleted.
Rewritten.
Rewritten. Okay, sorry. If the next hop is rewritten, then
you probably want to strip it.
Right.
Right. So that I think that text is missing. You probably want to clarify.
I'm going to add that.
Sure. Thank you.
Okay, thanks.
Okay, I fully agree with what Jorge has said. It's clearly too early to adopt this document or even to do an adoption call, because we need to agree at the IETF level, and especially in spring, if the SRv6 plus concept that you are trying to push is something that they want in spring. And if it is accepted, of course, this is a work that
Sure.
that we will address into the BESS working group.
Sounds good.
But we need to go step by step.
Okay, sounds good. Understood. Any other questions? Thank you.
Thank you. So I think we are done for today and for this IETF. So see you in Singapore.
And if you have the blue sheets, could you bring them to the front, please? Thank you.
Thank you very much. Sure, you're welcome. Thank you.